Right, hello again, and welcome to week 4. And stop talking, please. Hey, shh, shh, shh. It's my turn to talk, and will be for a couple of hours. Sorry, but that's the way it is. Today's attendance is about 22, 23, just so I can keep track of that. We've got a couple of things to do this week, but I'm going to start by having just a quick look at the Smiley exercise, which obviously the submission for that is just timed out, so good luck if you got it done. From what I've seen, most of you actually done very well. A lot of creativity went into it. I'm quite pleased at the efforts people went to try and make it look nice beyond just the kind of minimum requirements. And I will do probably on Wednesday. I'll do like a proper look at it to let you see the various techniques that help to make it look nice. But for just now, I'm going to just show you a quick example of one so I can illustrate something that I'm going to be expecting you to learn today. So here's the example. In fact, let me just do that. Okay, so this is just from one of you. It's quite a nice one, kind of movie style. Got the nice splat here, a nice bit of radial shading and stuff like that. Nice smile, thicker in the middle than it is at the sides, which is not entirely obvious how to do it. So well done. So that's very good. And so I won't show you all the code of it or anything. But what's nice about it is they've broken it up into like meaningful subparts, so it's not just one huge big function. So you can see that draw default smiley, it just draws it out of parts, starts with the base, does the smile as a separate thing. I'm assuming that they've been honest about it. If I were to then comment out the smile, very easy to just run it without the smile part. Yep, you can see that they've meaningfully subdivided the problem, which is what you're supposed to do. But that's not really what I'm going to show you. What I'm going to show you is a clever little trick. I'm going to do down here. So you can see that this is the driver function where we actually kick things off and draw the thing. Now, I told you to call it draw default smiley, and there's a reason for that, because that means to draw it at the default location, which is 200 across, 200 down, radius, whatever it was, right? 150, I guess. And that's fine, and it's nice, but if you had that smiley and you were using it in a game, maybe you wouldn't always want to be drawing it at the centre of the screen exactly that size. Wouldn't it be nice if you could draw it somewhere else and at a different size? And of course, you can do that, but one way to do that would be go and take your draw default smiley routine, it's down here, stick some parameters on it, give it an X and a Y and a size and stuff, and then rewrite it so that in all the places where you just hard-coded your X equals 200 or whatever, you'd have to go and modify it to use your parameter. But then, if you had done similar things with your blood splats, if you've got a bunch of magic numbers in there to make your nice blood curves look the way you want, you'd have to go and modify all them to add the X and the Y and to do anything else. Turns out it's a hell of a pain to do it. And as luck would have it, you don't have to. There's one of the little tricks that Canvas provides, because of it being context-based, that allows you to do things like this. I can actually take the context object before I call anything, and I can tell it to do translate. And then I put in some numbers here. I'm going to pick an X value and a Y value, both minus 50 for now. Right? So just notice this is a standalone line that is not inside the draw default smiley function, which I am not changing right now. But nevertheless, when I run this, it moves. And hopefully you can see why. I've told it to translate by minus 50 X units, so it'll move left 50, minus 50 Y units, it'll move up 50, so it moves the thing. Which is maybe not terribly spectacular, but it's the beginning of something useful. If you wanted to move it around, if it was a game object, this would allow you to do it. And the nice thing is, I've been able to do it without modifying the original code at all. Somewhat magically, I've changed the context. Now remember, I spoke about last week about this, that when you're doing the drawing API, you could have things where it's got parameters on it to specify what colour everything that you draw should be, or you could have the idea of the fill style, where you put the colour information in a context object and it just kind of implicitly flows through everything. Well, this is the same thing. The translation is set up in the context and then applies to everything that you draw, which means that even the blood splats and all the weird stuff, they all move as well. Everything just moves consistently. And translate isn't the only thing you can do with this trick. You can also do scale And that's also can be specified as an x and y, but I'll start with a simple one. Let me just do 0.5 and 0.5. So what do you think is going to happen if I do 0.5, 0.5 scale?
Shrink it by 50%.
Okay, so it's going to shrink down. Is it still going to be centered where it's centered? Is it going to be like in there but half the size, or is something else going to happen?
I think it's going to still be centered like that.
Okay, somebody thinks it would still be centered there. Actually, suspense. No, it actually moves a little bit as well. So why did it shrink and move? Because I didn't tell it to move. Why did it shrink and move?
Is it because you shrink it first and then translate?
So the person said, is it because I shrink and then translate? Actually, we can kind of ignore the translate at this point, so as that doesn't confuse us. I'll just take the translate out entirely. So let me just take everything out. We'll go back to square one, just draw it fresh, and I'll just do the scaling on its own, and it still does that little move.
Halving every value.
Correct. The person said, aren't you just halving every value? So that's what scaling is. Scaling is taking the x and the y's and multiplying them by something, or in this case, dividing them by 2, which is multiplying by a half. What that's going to do is everything's going to get pulled towards the origin. And the origin is not the centre of the display, and it's not the centre of the face. The origin is up here. So when you scale things, they're all being kind of shrunk towards this natural centre of scaling, which happens to be the origin, which is not always what you want, but it sort of mathematically makes sense, because it's like if you're just scaling the x's and the y's, what's going to happen? They're all going to get closer to 0. Okay? So in reality, imagine if I wanted to scale it, but keep it in its initial position. Maybe I didn't even want to do the translate. I wanted to just have it be right back in the centre, but half the size. Any ideas as to how I could do that?
Translated by multiplied and translated.
Okay, I think that was basically the insight. The suggestion was to translate it and scale it. Yeah.
Transform.
Okay, well, yeah, I think some of you are getting there. What you do is you can, if I just did the scale, you would see it would shrink it, but it would move it. And I could compensate for the move by then doing a translate to move it back to where I'd like it to be. So there are two ways I can do this. One thing is, if I just did the scale like that, that would take it from being centered around 200 to being centered around 100 effectively. And then I could fix that up by telling it to translate from where it is to 100 further across and 100 further down, like that. Okay? So that's part of the answer. Now, there's one thing you should note here, which is the ordering of these operations is a little bit strange. They're actually happening kind of in backwards order, like the scale is happening first and then the translate, even though the code is written translate then scale. I will try to explain that in a bit, but for now, just kind of live with the fact that it's slightly eccentric. So this is one way to do it, but this is a little bit annoying because it means that the amount I have to translate by kind of depends on how much I scaled by, and you end up having to keep these two things in your head all the time. It's kind of annoying. The standard trick for doing this is to just get the offsets out of the way right at the start. So what you do is you take your object in its initial form, like so. Sometimes it's a little bit slow at refreshing. And if I translate it all the way back so that it is centered on the origin, which in this case means taking off 200 and 200, right? Then it will be like that, centered on the origin, so, you know, just like the tip of the nose, we can't really see it. Why center it to the origin? Well, once you put things in the origin, scaling them works sort of totally the way you would expect. You know, it just shrinks them without moving them. That's the important thing, right? So this will now let me shrink it without moving it anymore. It'll still be centered at the origin. And then having done that, I can then translate it back to whatever I want it to be. I actually want it to be at 200 by 200. So I've taken 3 little steps. I translated it to the origin so that I could scale it naturally, and then I translated it to where I actually wanted it to be. And that is commonly the way these things are done. While we're here, there's some other things we could do. I've used a uniform scaling. I used a half on both axes, but I could do weird things, like I could say make the y scaling 1.5 instead. What will that do? Stretch it. Like that. which is basically the trick we use to create the ellipse. The ellipse used this trick to distort a circle. So that's you do there. Right, and there are other little things we can do. I can do rotates, which turns out to be a thing you might want. So if I were to do a rotate, so I'll just tell you rather than being awkward about it, the rotate angles are of course in radians, right? So I'll just use one radian is like about 60 degrees or something like that. So you get an idea of what that is. It's, you know, it's between 45 and 90, right? You can kind of intuitively see it. So what do you think will happen if I tell it to rotate it by 1 radian? What's it going to look like?
Rotates around the origin.
Rotates around the origin. That's the right thing to realise here. So it does that, which actually in this case knocks it off the screen. So I'll do it a little bit less than that. I'll do it by a half a radian instead, so you can still see it. And it's like that. But you see, it's nice. It's rotated. You know, all the parts are rotated, which is cool. But it has swung the whole shape again. So again, the centre of the object has moved, and that's not really what I wanted. I just wanted to rotate it. So what should I have done to rotate it without swinging it round?
Translate to the origin.
Translate it to the origin and do the work there. Now, actually, rather than just repeating myself, we've already got a piece of code where we translated it to the origin. We did this, right? Minus 200, 200, took it to the origin. So what I could do is I can stick the rotation in there. Oops, I'm just trying to line up my nesting there, right? So again, take the original shape, move it to the origin, do the rotate at the origin where it won't screw anything up, do the scaling at the origin where it won't screw anything up, and then translate it back to where you want it to go. Boom. Okay, and you get all the nice effects. We've got it shrunken and rotated, but we haven't offset it from where we wanted it to be. Now, we didn't have to move it back to 200 by 200, of course. You know, the whole point of this was to let us put it to other places. If I wanted to put it at 300 by 150, that's all I need to do. I just say 300, 150. The nice thing about this approach is that this is just the actual XY coordinates that I want. I haven't had to do silly things like work out the effect of the scaling or the rotation or anything, because we did everything in the kind of natural coordinate space at the origin, which means you just say where you want it to go, and it goes there. So now we can rotate it, scale it, and translate it to where we want it to go, all without modifying the original code, which is nice, because it saves you a lot of work. You'd have to go through and change a lot of stuff, and you don't have to. And also, there's an important tip in life is that if you don't have to modify the old code, then you haven't broken it. And that's a nice thing to know. It means that the old code stays working the way it was, but you just wrap something around it that now lets it do something else. So this is a technique in computer science called composition. It's very popular in functional programming languages, very popular in Scheme and Lisp, where the idea is that you build your system out of little parts, and each part works and does its own thing very well, and then you compose it with something else to build like a pipeline of things, and they all just sit on top of each other until eventually they do the big thing that you want. And that's very much what's going on here. We're composing a whole bunch of operations. And that's partly why we have this weird thing of it appearing to all happen in backwards order. Because what I'm doing is, when I'm modifying the context, I'm basically chaining together elements of a pipeline, right? But the thing about the pipeline is all the water is being pumped in from the end, so it comes in backwards, right? So when you build up your pipeline, you say, I want to do this, I want to do that, I want to do that, and then I want a bunch of vertices. And the thing is, the vertices then come in through the pipe like that. That's how you can imagine it. So what's happening here is when we get down to drawing the smiley, we're talking about, you know, really drawing things at certain positions. And those positions get put through the translator unit, and then they get through the rotator and the scaler and the translator again, and it goes click, 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 and you get the end result of the screen. And that's how it works. And it's actually even cleverer than that. You might think that doing these 4 operations, all of which have to remember be applied to every single part of their smiley, so that's like, you know, every single splatter of blood, all the little details, and the more detailed it gets, you would think the slower this will get, because you're having to do all these cumulative operations. It turns out you're not really. It turns out all of these operations here, they all kind of collapse onto one another. And as you build them together, they all just get turned into one magic operation that does all of the parts. Does anyone know how that is achieved? How am I able to flatten all these operations together so that it actually only ends up being one operation at the end.
Matrices?
What was your suggestion? Yeah.
Yeah.
That's the answer. It's a matrix, a proper matrix. If you've done enough geometry, or if you've done the 3D course, or you will maybe do it in the future, you'll find that a lot of graphics work is based on using matrices to manipulate your points. And I really wish they taught this more in school when you get taught matrices, because my experience was you get taught them and it's like, they've just run out of things to teach us now. They're just inventing stuff, aren't they? It's like, what's the point of this ridiculous two-dimensional numbers? Yeah, they tell you can solve simultaneous equations with them, but to me, matrices would be, I mean, I actually did know this when I was young because I read computer books, but if you knew that matrices are like a really important part of computer graphics, I think you would find them more interesting, because one of the things that you can do if you multiply something by a matrix, it can represent things like shifting and rotating and translating. You can create matrices that have that effect. And in order to do a whole bunch of effects one after the other, you multiply the matrices together. So what's actually happening here is when I do these things, I'm creating a matrix inside the context object. And every time you do another one, it multiplies the matrix by another matrix. So this is just 4 matrix multiplies, which doesn't take very long to do. And we end up with one combo matrix that does this whole operation, so that when you apply it to your several hundred points, it all goes through just one matrix multiply. So this is actually nice and efficient. So that's it. So with this knowledge, I could now create a little function here called, draw smiley at, and I would take in an x and a y and a rotation angle and a scale, which would just be parameters in here. Right? They would just be parameters of the function. And it would just do that and then call the standard smiley drawer, and you would get this nice version here. One thing you have to remember though, if you do all this, at the end you might want to put the matrix back to the neutral identity matrix. Otherwise, these things will apply to everything else that you draw, which will be a bit crazy. So the thing you tend to do is, when you do a function like this, you save the state when you come into it, just so that it remembers. I keep pressing the wrong key. Just so that it remembers, God's sake, my hands are off by 1. You save the state of the matrix on the way in, and then you restore it at the end, and that way it stops you having side effects that would percolate through the rest of your program. So you do that, which you won't see anything here because all I've done is added a little bit of a kind of safety mechanism, but if I've done it right, nothing should change. Damn it! Oh yeah, because what did I do wrong? Restored prematurely. I'm an idiot. I restored. So in a way, it illustrates that the restore worked, right? The restore took me back to the neutral state. What I meant to do is draw the smiley and then restore things so that it goes back to normal at the end. So hey, well done. And that's how you generalize the smiley. It might come in handy at some point. Who knows?